Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over the pH scale, quantifying acidity and basicity. So let's get into this. First we'll talk a little bit about the pH scale in a little bit, but first I want to talk about what pH is and how you calculate it. So first, pH. What is the pH? The pH of something is going to be equal to the negative log of the H plus concentration or the hydronium concentration. So let's talk a little bit. Let's unpack what this means. So what is pH? What does that mean? So the H means refers to hydrogen. The P, there's a little bit of controversy or disagreement over where the P comes from, but I think overall the agreement is on that it refers to power in some way. So it either refers to capacity of the of hydrogen or the power of hydrogen or something like that. And so that idea of power brings us to this idea of like raising something to the power of another number, right? So exponents is something we should be thinking of. And so what is also this log, right? You might have seen log before, you might have used log before, but what exactly is log? So here I have kind of an explanation of what we mean by log. So here, I'm going to be talking about log base 10. So what is log? So the log of a number is the exponent to which 10, the number 10 must be raised to obtain the number that you're talking about. So the log of a particular number is going to be the exponent to which 10 has to be raised to get to that number. So this is often called, since we're using 10 is the number we need to raise the power to, or raise this exponent, we call base 10. So a lot of times you're going to hear someone say log base 10, or you might see the log with a little 10 subscript after it. We're talking about base 10, and the base is the number to which we have to raise. We have to have the exponent and raise that number to. So we could have log base 6. So the log of a number base 6 would be the exponent to which you have to raise the number 6 to get to that number. So, but we use base 10 usually because that's a simpler base to use. So, for example, if I have my number 10 and I want the log of that number, and we're thinking, okay, well, log is the number, or I'm sorry, the log of a number, or in this case, the log of 10, is the exponent to which I must raise 10 to obtain my number 10. Well, in order to obtain the number 10, I need to raise 10 to the 1 power. Sorry about that. Lights again. So in this case, the log of 10 is going to be 1 because 1 is the exponent that I need to raise 10 to in order to get 10, right? So 10 is equal to 10 raised to the power of 1. So for example, 100 also, like, okay, so what is the log of 100? Meaning, what is the exponent to which I have to raise 10 to in order to get the number 100? Well, that's going to be the power of 2 because 100, in order to get 100, I have to take the number 10 and raise that to the power of 2 in order to get 100. So the exponent to which I need to raise 10 to in order to get to 100 is 2. So that's the log, right? Same thing for log of 0.01. Well, what's the log of this number? What number must I raise 10 to, right? What power of 10 do I need in order to get 0.01? And the answer is -2, because 0.01 is equal to 10 to the -2 power, or another way to put it is 1 divided by 100. So -2 would be the log of 0.01. Okay, so I hope that helps explain what log is and what we mean by that. So here, if we come back to this equation here, So the pH is the negative log of whatever the H plus concentration is. So let's say that our H plus concentration is 1.0 times 10 to the negative 3. So we're going to plug that into our equation here. So we're going to have pH is equal to the negative log of 1.0 times 10 to the negative 3. So remember, so we're going to take the log of this number. Well, again, thinking log is the number, the exponent to which we must raise 10 to in order to get to this number. So 1.0 times 10 to the negative 3. So what exponent must we raise 10 to? Well, that's going to be negative 3. So negative 3 is the exponent that we must raise 10 to get to this number. So when we take the log of this number, we get negative 3. But remember, we got to take the negative log. So we're taking the negative of a negative 3, and that's going to be positive 3. So the pH of this amount of H plus ion, that concentration of hydrogen or H plus, is going to give us a pH of 3.00. And so that's how you find the pH, by plugging in the value of your H plus concentration, taking the log, and then taking the negative of that to get your pH. Now, there's one important thing I want to talk about with regard to significant figures and decimal places. So the rule is, whenever you take the log of a number, so you take the log of a number, your answer that you get for the log should have the same number of decimal places as the number of significant figures in the quantity you started with that you took the log of. So you'll notice here that I have 2 significant figures here. So that should translate to 2 decimal places in your answer when you take the log. So notice I have 2 decimal places here because I started off with 2 significant figures. And if you go in the opposite direction, right? So if you start with a pH, or you start with this and you go to concentration, then the number of decimal places should translate into number of sig figs in your H plus concentration. So you want to keep this in mind when you're trying to figure out number of sig figs in your answer. Okay. So finally, what I want to talk about is the pH in relation to acidic, basic, and neutral. So since, remember, the pH scale that we're working with is a pH scale of 1 through 14, or maybe 0 through 14 might be better. So 0 through 14 or 1 through 14. So here, when you do a calculation, and this is at 25 degrees Celsius. This only works at 25 degrees Celsius, and I'll explain that in a moment why that is really quickly. But here you want to remember, okay, so if I take the pH of some water, now notice here, we know, let's remind ourselves that in pure water, the pH or the H plus concentration is going to be what? We learned that H plus concentration is going to be equal to what? 1.0 times 10 to the negative 7. So that's the pH, that's going to be the H plus concentration of pure water, right? So if you take the negative log of that, then that's going to be the pH is going to be equal to 7. So in neutral water, which has equal amounts of H plus and OH minus, the pH is equal to 7. So here, pH is equal to 7. We have neutral water. Okay. If we have our H3O plus concentration, our hydronium concentration is greater than 1 times 10 to the negative 7. So this means we're in acidic solution here, right? Because our solution has a concentration of H plus much higher than the 1.0 times 10 to the negative 7. So we have an acidic solution here. We take the pH of that, and you find that the pH is lower than 7. So pHs that are lower or less than 7 are acidic, And that means also that if you have a pH that's greater than 7, that's going to be basic. Now, as I said, this only applies under the condition of pure water or water, for example, and that water is at 25 degrees Celsius. So if you're not dealing with water, if you're using a different solvent, then the pH scale here, 0 to 14, does not apply. If you're not at the temperature of 25 degrees Celsius, this 0 to 14 does not apply. And the reason for that is we said before that the Ka value, or the equilibrium constant, right? K, that equilibrium constant. So we either Kw or Keq, the equilibrium constant of various reactions, or Ka, right? The ionization energy, or the ionization constant for acids. So those sorts of things. All of these equilibrium constants depend on temperature. And so therefore, Kw depends on temperature. So if you change the temperature, you change the value of Kw. So at 25 degrees Celsius, Kw is 1.0 times 10 to the negative 14. If you change the temperature, that is no longer the case. And so therefore, your pH scale will change. So, and this also, again, think about whether or not water, or the auto-ionization of water, is an exothermic or endothermic reaction. As we said, the changing of the temperature according to Le Chatelier's principle, if you change the temperature, if it's an exothermic reaction, it's going to switch one way. If it's an endothermic reaction, it'll move the other way. So you want to think about, okay, what is auto-ionization of water? Is it exothermic or endothermic, right? And so you can think about that, and then if you understand whether it's endothermic or exothermic, you can think about, okay, well, if it's one way or the other, if you raise the temperature, what's going to happen? Which way is it going to go? So think about that, and I hope this was interesting and helpful. And if you enjoyed this video, please hit that like button right there, and subscribe to my channel. Hit that notification bell so you can be notified by other videos I put out. If you have any questions, or if you are curious about anything that I said in this video or other videos, please put a comment in the comment section. Let me know what you think and what your questions are. Thanks for joining me. Have a great day.